Hi, thanks very much for having me. I'm going to talk about global famine after nuclear war, and this work is funded by the Open Philanthropy Project because the federal government won't give us money to study this, although they should. This is the team I'm working with. These are climate modelers, ocean modelers, crop modelers, and people burning cities to try and calculate how much smoke there is. So and we published a number of journal articles about our work, and they're all available, but I want to try and explain to you without having to read all those articles. This is our beautiful planet. But after a nuclear war, it might look like this, with a cloud of smoke covering the northern hemisphere and then gradually moving down to the southern hemisphere and blocking out the sun. And if there's enough smoke, temperatures would get below freezing even in the summer. We call that nuclear winter. It would get cold and dark and dry. This obviously would have an effect on agriculture. 40 years ago, the Swedish journal Ambio had a special issue on the impacts of nuclear war. And Paul Crutzen and John Birx wrote an article about ozone. And they said, by the way, which is a photochemical reaction, by the way, there might be fires and might be smoke. And the climate modeler said, whoa, really? So Russian team, Alexander Finstenchikov, an American team, Turco Toon, Ackerman, Pollock, and Sagan, began to calculate how the climate would change. And they both found out temperatures would get below freezing. It would be nuclear winter. Now, here's a graph that Sig showed. This is updated up to the present using data from Matt Korda and Hans Christensen. There was an arms race, and then it ended. Why? Well, Crutzen and Birx's paper was published in 1982. The pioneering Russian-American papers were published in 1983. I published a paper, and another group in the US published a paper, and then the arms race ended. Now, we scientists who are, to test our theories, we use models, we use data, but what do historians do? They just ask the people that made the decisions. That's a very different way of doing research. Another theory is that the Soviet Union ended, but the Soviet Union ended 5 years later, so the arms race was already over. And by the way, it's not zero. We still have 10,000 strategic weapons. So who made the decision? Ronald Reagan and Mikhail Gorbachev. And Reagan said, a great many reputable scientists, he called us reputable, are telling us such a war would end up just no victory for anyone because we would wipe out the earth as we know it. You think back to natural calamities in the 1800s, volcanoes, so the weather so changed that there was snow in July in many temperate countries. They called it the year in which there was no summer. Now, if one volcano can do that, what are we talking about with the whole nuclear exchange, nuclear winter? And Gorbachev said models made by Russian and American scientists showed that a nuclear war would result in a nuclear winter that would be extremely destructive to all life on Earth. The knowledge of that was great stimulus to us. So because the American and Russian scientists gave the same answer, they accepted it. That was 40 years ago. Why am I here talking about it? Well, I want to ask two questions. Although the Cold War and the arms race are over, could the remaining nuclear arsenals still produce nuclear winter? As we talked about this morning, there are now 9 countries with nuclear weapons. What if a couple of the new nuclear countries had a nuclear war? What would that do? And so the answer is yes. It would last for at least half a decade and kill most of humanity. And it wouldn't be nuclear winter as the temperatures wouldn't get below zero, say if India and Pakistan had a nuclear war. There would still be huge climate change and huge impacts. So we use our crop models to actually calculate that risk. It depends what kind of smoke it is. If trees burn, it's kind of light colored smoke, but if it's industrial areas based on oil, plastic, asphalt, you get this black sooty smoke, and that's more effective at absorbing sunlight. So this is a map drawn by the US Army about the cities in Japan in the summer of 1945 that were firebombed. And this was not in my history books. I discovered recently, probably not a lot of you know about that. On March 10th, 1945, General Curtis LeMay, who was in charge of the US Air Force, said, let's burn Tokyo. They sent 2 planes that painted a flaming X with napalm and then more than 300 planes. And in that one night, more people were burned to death than ever before in 24 hours in the history of our planet. And then every 3 days or so, they sent out fleets of planes to bomb other cities. And this is a map of all the cities that were burned. 800,000 people were killed, civilians. Well, they said, oh, they've all got a drill press in their backyard because the bomb site didn't work to bomb military targets during the day. And of course, they could shoot at you then. It was clearly war crime. So Tokyo was the size of New York. The 68th and 69th cities that were bombed were Hiroshima and Nagasaki. And the only difference was, it was already US policy, the only difference is that it just took one bomb for each. So Hiroshima was bombed on August 6, 1945, a 15 kiloton bomb. That's 15,000 tons of explosive power of the bomb. It's very small by today's standards. So-called conventional weapons are 1,000 times smaller than that. And the current arsenal is still so large, if you drop one of these every 2 hours, every day for 77 years, you still couldn't use up the current arsenal. Now, the picture on the left is the mushroom cloud from dropping out of Hiroshima. The one on the right was taken 3 hours later. This is what we call a pyrocumulonimbus cloud. It was a thunderstorm produced by the fires that were started. Ed talked about all the effects, but one of the main effects is fire. Hiroshima burned, and it pumped this smoke up, and it's pumped the smoke up into the stratosphere. That's what causes climate change. It's the smoke that goes up in the stratosphere, lasts for years, absorbs sunlight, and makes it cold and dark at the Earth's surface. This is what one of the survivors of Hiroshima remembers, the fires. And this is what Hiroshima looked like afterwards. Now, 3 days later, they dropped the Fat Man bomb on Nagasaki. Here's a picture at the museum there, Fat Man and bomb. And this is the mushroom cloud from Nagasaki, 20 kilotons. And this is what it looked like in Nagasaki. Now, Ed was talking about data. Fortunately, we don't have many cities that burn. But there was one, San Francisco, 1906, after the earthquake. And Jack London, the famous author, was asked to write an article about it for Collier's Weekly. And he said, within an hour after the earthquake shock, the smoke of San Francisco's burning was a lurid tower, visible 100 miles away. That's 160 kilometers for you. People don't understand miles. And for 3 days and nights, this lurid tower swayed in the sky, reddening the sun, darkening the day, and filling the land with smoke. I watched the vast conflagration from out in the bay. It was dead calm, not a flicker of wind stirred. Yet from every side, wind was pouring in upon the doomed city. East, west, north, and south. Strong winds were pouring upon the doomed city. The heated air rising made an enormous suck. Listed the air, listed the fire of itself built its own colossal chimney through the atmosphere. That's again a classic description of a firestorm pumping smoke up into the atmosphere. And this is what San Francisco looked like afterwards. Some of the stone buildings still remain. So this is the current arsenal. This is from, it's a year old now, from the Nagasaki University. I don't know if they've had their new thing out. And these are the 9 countries. These are the US bombs, the Russian bombs, and this wedge is the other 7 bombs. Let me blow it up so you can see a little bit better. The blue are on submarines, the red are land-based, and the green are on airplanes. So this makes me ask a few questions. If you wanted to threaten deterrence, threaten to put a bomb on the capital city of your enemy so they wouldn't attack you, how many bombs would you need? 1. Okay, so maybe you need 2 in case the first one doesn't work. So 100 is more than enough. And all these other countries have decided to have a few hundred. Why do the US and Russia still have more than 5,000? And what about all the other countries who don't have any weapons at all? What can we learn from them? Why? We know how to make bombs. We can get the material. Why have other countries decided not to have? So it's about 18 years ago now at a conference, Brian Toon and Rich Turco walked up to me and said, somebody asked us what would happen if India and Pakistan had nuclear war. They have nuclear weapons now. So we decided to calculate it. And you can imagine along the Kashmiri borders, a skirmish getting out of hand. In fact, they've had actual small wars about that, several of them. So at the time, each country had about 100 bombs. We assumed that they were 15 kiloton size of Hiroshima. That were easiest to make. We said each one used 50 of them on the other country, 100 bombs, and 27 million people would die directly. Half the number of people that died in World War II. It would produce about 5 or 6 million tons of smoke. So we used a climate model to do the calculation. You can read all the details on our papers. This is a movie I made. This is where the smoke would go. And this is the vertical distribution. This is the tropopause. We live down here in the troposphere where there's rain that washes particles out of the atmosphere. But the smoke would be heated by the sun, lofted up into the stratosphere, and blown around the world and last for years. This is the climate change that would result. This is the observed data, global warming, that big problem that I'm working on. This is instant climate change. And it would be global climate change unprecedented in recorded human history. colder than the Little Ice Age. And 40 years ago, we didn't have very sophisticated climate models. So we decided to redo the calculation for the US and Russia, because was nuclear winter real? And that would produce, the scenario was 150 million tons of smoke, not 5. And here's a movie of the smoke. And this is the temperature change a year later at the surface of the Earth. This is yes.
And I'm sorry to interrupt, but is this every one of the weapons being used? Or is it like when you're seeing this plume of smoke, how many weapons are being used? Oh,
I'll show you for each scenario, I'll show you the number of weapons. 1 second. And this is, we said, let's see if it's really nuclear winter. So just by chance, we took a place in Ukraine. We looked at the temperature, and this is in degrees Celsius. This is freezing. The normal climate, the black line, it gets 25, 70, or 80 degrees in the summer, below freezing in the winter. If the war started May 15th, temperatures will plummet below freezing and stay below freezing for a couple of years. Clearly, you can't grow any crops. And now we've taken the most modern climate models and redone this calculation, both for India, Pakistan, and for the US. And now India and Pakistan have a small arms race going on. They have more weapons. The weapons are a little bit bigger. And so these are the scenarios to answer your question. For US and Russia, it's 4,400 weapons of 100 kilotons. For India, Pakistan, the first thing we did was 115 kiloton weapons produced 5 million tons. A teragram is 1 million tons. And then we looked at scenarios where there were more weapons and bigger weapons. And this is the number of people from the direct casualties. It would be horrific, millions of people. But as I'm going to show you, the number of people that would die from starvation is more than 10 times this. So we calculated how the surface temperature would change. And for these scenarios, IP is India, Pakistan, US, Russia, temperatures would go below 10 degrees below normal, and it would last for a decade. For 5 years, it would be very cold. Just to calibrate this, during the last ice age, when there were mile-thick ice sheets covering North America, global temperatures about 5 degrees Kelvin below normal, about here. So these are ice age temperatures for several years. It wouldn't produce an ice age because the sun would come back. But what we really care about is how would it affect our food? So how would temperature change, how would climate change affect food? It would be dark, it would be cold, there'd be less rainfall. All of those things would affect agriculture. And there's a lot of other things, toxic chemicals, fuel, machinery, distribution system, enhanced ultraviolet radiation, because it would destroy ozone. We are still working on this. We haven't included this in our calculations yet. And we had a paper last year in the journal Nature Food, which got a lot of publicity. I wanted to call it Global Famine After Nuclear War, but the editor wanted a longer title. So it's Global Food Insecurity and Famine from Reduced Crop, Marine Fishery, and Livestock Production due to Climate Disruption, Nuclear War Injections. We looked at agriculture, we looked at fisheries, we looked at livestock. And we got the data from the Food and Agricultural Organization of every country. What crops do they grow? What's their diet? How much do they import? How much do they export? We modeled the main crops, corn, rice, soybeans, and wheat, and grasses, and we calculated for how much would be available for livestock. And this is the temperature change over crops. It would be much more than I showed you before, which included the ocean. So, and this is the change in the number of calories available globally average to eat. So for US-Russia war, there would be 10% of the normal food. For India-Pakistan, it could be 40, 50% reduction in food for years. So how many people would die? Well, we made a very simple calculation. We said the normal food supply is about 60 days worth. We don't know when the war would take place. So let's assume all the food that's stored gets eaten. And then people in the second year have to depend on food that they can grow. And so for the India-Pakistan case, 37 teragrams, this is the number of people that would be starving at the end of year 2 in each country separately. We also assumed there'd be no international trade. People would hoard their food like we used to do toilet paper. And in the high latitudes, Canada, Russia, most people would die from a war between India and Pakistan on the other side of the world. In the tropics, there would be less of an effect. For a war between the US and Russia, however, it looks really grim. Only a few places would there be enough food for people to live in places like Australia, Argentina, because they don't have a big population, they're a huge exporter of food. But if you think the refugee problem is bad now, just imagine boatloads of starving people on their way to Australia. So this is not a solution, just move to Australia. And we calculate how many people would be alive at the end of year 2. So this is the numbers I had before, the direct effects. This is the number of people that would die after because of the indirect effects. A war between India and Pakistan could kill 1 to 2 billion people. The US-Russia war could kill most of Earth's population. You notice this is more than 10 times the direct effects. And this is well, that's why I asked the question this morning. This is not taken into effect at all in planning for nuclear weapons. We're trying to get them to pay attention, but it's like people that believe in Trump, they just can't use data. So, and we didn't include in these calculations effects of ultraviolet radiation, effects of ozone changes, more complex economic responses like some international trade, and we're working on that too. So what are this is all theory, as I talked, this is all model calculation. What else can we use for analogs? Well, it gets cold in the winter because there's less sunlight, less energy, gets colder. It gets cold at night because there's less energy. I showed you already about cities can burn, Martian dust storms, asteroid impact killed the dinosaurs. Ronald Reagan mentioned volcanic eruptions. And I'll just show you a couple examples. There was a big forest fire in British Columbia in 2017, and it pumped smoke up into the stratosphere. And we modeled it with the same climate model we used to calculate nuclear winter effects. We published a paper in Science, and it said the smoke plume rose from 12 to 23 kilometers within 2 months, owing to solar heating and black carbon. Here's a graph. Some of these lines are observations from satellites, some are the model simulations. So this process of the smoke going in the stratosphere and being lifted, we actually observed, and it helps to verify our models. This is much less smoke than we're talking about. This is the Tambora volcano, which erupted in 1815, producing the year without a summer that Reagan mentioned. And it's the biggest eruption in the past 500 years. And there's a lot of things being written about it. This is a book from Gillen Wood. For 3 years following Tambora's explosion, to be alive almost anywhere in the world meant to be hungry. There was famine everywhere. This is a graph of temperature in New Haven, Connecticut, how cold it got for a couple of days. And there was famine in India, in Egypt, and in China. So the conclusions are that the current nuclear arsenal can produce nuclear winter, and a nuclear winter could kill most of humanity. In the US, NATO, Russia war, more people could die in India or China than in the US or Russia, even if no bombs were dropped. So I guess I've got a couple of minutes left. Let me say a couple other things. This is a map showing all the countries that have no nuclear weapons in blue. There's no nuclear weapons in the Southern Hemisphere. There's one country in the Western Hemisphere of the US, there's 2 in Europe, and 6 in Asia. The yellow ones are in treaties with countries with nuclear weapons. They somehow think that that's protecting them. But many countries have decided they're better off without nuclear weapons. Now, I added this. Brian Toon and I wrote a paper in both the Atomic Scientists, self-assured destruction. We said it's sad, it's not mad. If we threaten to use our nuclear weapons to deter you, we're going to kill ourselves. We're threatening, we're a suicide. By the way, we tried to get it published in Foreign Policy, but they weren't interested. So, Alexander Kement from Austria, the ambassador and International Campaign to Abolish Nuclear Weapons, organized 3 conferences to tell people about the humanitarian impacts of nuclear war. I went to 2 of them in Mexico and in Oslo, and then they went to the United Nations and they got a treaty to ban nuclear weapons. They avoided the Security Council with the veto power of the nuclear nations and got it through. And there was very little publicity about it, but there was one article in the New York Times. The treaty is reached. Now comes the hard part, getting the nuclear nations to pay attention. So the closest we ever came to a nuclear war was in Cuba, the Cuban Missile Crisis. This picture in Havana, this is one of the Russian missiles that were there. There were 36 missiles. Each had a 1 megaton warhead, 77 times more powerful than Hiroshima. And I was invited to Cuba to give a talk about this, and Fidel Castro showed up. And so he sat for an hour listening to me, and he gave me his autobiography to practice my Spanish. And then the next day at my hotel, I got this envelope from Commander-in-Chief Fidel Castro a picture of us that he autographed. He got dressed up for the picture. And then he blogged the next week. While the US and Russia each committed to reducing their nuclear arsenals down to 2,000 weapons in Prague, that's of course the New START Treaty, the only way to prevent global climate catastrophe would be by eliminating nuclear weapons. And then I got a private tour of Havana afterwards, and he said, can we record your talk? And they showed it on nationwide television in prime time. So I walked into a hotel to see if I was on TV, and there was a Julia Roberts movie on the TV, a bootleg one. You change the channel, and sure enough, there I was giving my talk. And what that taught me is a professor giving a talk is not nearly as effective as something which captures your emotion. So if anybody knows how to get a movie made with this beautiful scientist in St. Petersburg who's in love with a handsome scientist in Oak Ridge, meanwhile on the Kashmiri border, and so but that's about as far as I've gotten. So if you could do a really good job, that would be useful. I met him once again a year later in 2011. I sat across the table from him for more than, I brought him a Rutgers baseball cap because I didn't know I was going to meet him the first time. He went the whole time telling me about the Cuban Missile Crisis and everything. So, and then we shook hands. He said, "You're taller than last time." So I said, "Okay, I can solve that." And then last year, a miracle occurred, and I got to share the Future of Life Award with other people that worked on nuclear winter. That's given every year by the Future of Life Institute for people, including people like Vasily Arkhipov, who decided not to launch a nuclear torpedo in the Cuban Missile Crisis. And so Paul Crutzen and John Birx, Rich Turco, Brian Toon, Carl Sagan, Gary Senchikov, and me, and Jeannie Peterson was the editor of the MBO. And and the people that ran this set up a research program, $4 million to fund more nuclear winter research because they know the federal government isn't doing it. And so we just announced that Alex got one of the grants, I got one of the grants. So maybe we'll learn more about this. And
sure, Alan, sorry, we have to kind of wrap up because the next speaker is already waiting.
Okay, I'll finish with this. When Beatrice Finn accepted the Nobel Peace Prize for getting this treaty done, she said, "The story of nuclear weapons will have an ending, and it's up to us what that ending will be. Will it be the end of nuclear weapons, or will it be the end of us? One of these things will happen. Only rational course of action is to cease living under conditions where our mutual destruction is only one impulsive tantrum away." Thank you.